I can honestly say I've never said this before, but today we're talking about rationalizing the denominator. If I tear this whole sentence apart, Jeremy Schwartz, what do you suppose it means to rationalize the denominator? First of all, what is a denominator? The bottom number. What's it mean to rationalize something? Well, let me tell you, okay, you're either rational or you're irrational, and this is talking about this. If you have an irrational number in the denominator, in math, we don't like that, okay, because you have a number that doesn't make sense in the bottom, and I don't know why, but this, you are not allowed to have an irrational number on the bottom of a fraction. Again, I don't really know why, it's just the way it is. So when they talk about rationalizing the denominator, they talk about changing this fraction into a fraction that doesn't have an irrational number on the bottom. Okay? Now if you go back the old school way, as Lucas goes through his little case there, you finding what you need there, Lucas? I love it. I really do. It's all business. Going back to when you change any fraction's denominator, first of all, I want to keep it equal. Let's go back to the fraction Jackson just did over there when he took 1 over 14 and it was, what, 1/2? When you added 1/2 to 1/14 and I wanted to make an equal fraction to 1/2, what did I do?
Multiply.
And what did I multiply by?
7.
Multiply both the top and the bottom by 7. Why? Because 7 over 7 is the same as 1. When you multiply things by 1, you don't change them. Same thing we're going to do here. What could you multiply the square root of 3 by to change it from an irrational number to a rational number? That's what you have to think about, John. The square root of 3. So the deal is this. You multiply this times the square root of 3. What's the square root of 3 times the square root of 3? 3. But whatever you multiply the bottom by, in order to keep it the same, you have to multiply the top by. So 1 times the square root of 3 is also the square root of 3. You are allowed to have an irrational number in the numerator, but not in the denominator. And this is the mathematically accepted way to do this. And no, you can't cross-cancel the 3 with the square root of 3 because they're not the same thing. Okay? You know, the square root of 3 is close to what? It's 1.414 something? Is that 414 or 7 something? 1.7 something, isn't it? Square root of, I should probably know this.
It's 1.732.
Square root of 3 is,
1.732.
yeah, 1.732. Okay. You can't just cross this off and say, well, that's the square root of 1 and blah, 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 because they're not. Square root of 3 is not the same number as 3. This, though, is acceptable. This really is not. So if you saw this and they told you to simplify it, that's what they're asking you to do. So let's look at a couple problems they give us. And it's really an easy thing to do. Just multiply the top and the bottom by the same little thing. 3 over the square root of 5 would end up being what? I'm going to multiply top and bottom, Jack, by?
The square root of 5.
The square root of 5. And when you end up doing that, you get 5 on the bottom, and on top you get 3 times the square root of 5. And that is typically, by the way, that, people sometimes don't catch this, but this is the same thing as 3/5 times the square root of 5. Same thing, just written a different way. Sometimes math folks will throw this at you and people get confused. Remember, if you have the square root of 5, it always goes with the number on top if you're writing it in complete fraction form like that. How about this one? 6 over the square root of 3. Here's a good one because this actually does simplify out. Multiply both top and bottom, Lucas the Spaniel by?
By the square root of 3.
And you end up with 3 over 6 times the square root of 3, correct? And this can be simplified. Why? Because 3 goes into 6. This is the same as 6 times the square root of 3, and since 3 goes into 6 twice, you end up with 2 times the square root of 3 is your answer. I love rationalizing on the denominator. How about the square root of 3 over the square root of 2? What would you get for that? If you did all that out, you would get whatever.
Square root of 5 over 2.
I agree with the 2 part, but the square root of 3 times the square root of 2 is
Oh, 6.
square root of 6. You're not adding, it's multiplication. And you couldn't, by the way, you couldn't add those together anyways. You can't put a square root of 3 with a square root of 2. They're not like terms. Okay, it's multiplication and multiplication only. How about one more? 4 over the square root of 2? If you simplify 4 over the square root of 2, we'll do one more too. 2 over the square root of 3. 4 over the square root of 2, Hannah Nuzzo. Don't say, it's probably not right. Square root of 2, square root of 2, you end up with,
2 times square root of 2. That.
I mean, well, you end up with, you ended up with this, right? And then you cross the 2 with the 4 and got 2, yes. The answer is 2 times the square root of 2. And that last one on the bottom, 2 times the square root of 3 over the square root of 2 would be, survey says, Nikki, how would you get the answer for this? No, you just, this is a lot like when I wrote all that book report stuff on the board. Lucas Spatio?
Square root of 6.
What?
That's square root of 6.
What happened to this 2?
Alright.
I was just checking. You get a normal 2 and then 2 times the square root of 6 and then 2 goes to the 2, so you get. Just checking.